clear. Next one. Next question. This next question is derived from a most popular theorem which we call it as Fermat's little theorem. Fermat's little theorem. This Fermat's theorem is derived from little theorem is derived from Fermat's theorem. It is just one step. If you do the next step, you will get Fermat's little theorem. Fermat's theorem says a power p minus 1 divided by p, it is 1 when a and p are co-prime. When a and p are co-prime and p is a prime number. A power p minus 1 when divided by p, reminder it is 1. When a and p are co-prime. Now see here. Suppose if p is a prime number, if p is a prime number, a is a natural number. A is a natural number. A power p minus a is always divisible by p. A power p minus a is always divisible by p. A power p minus a is always divisible by p. From where you got these? Suppose see here. For example, 3 power 6 divided by 7, it is 1 according to this theorem. Suppose if I take 3 power 7 into 3 divided by 7, it is 3 power 7. Okay, I'll do like this. 1 minute, sir. Three power 6 divided by 7, it is nothing but 3. Now listen carefully here, sir. Suppose if I write it as 3 power 7 by 7. 3 power 7 by 7 is 3 into 3 power 6 by 7. Yes or no? 3 power 6 by 7. What is the remainder? 1. 1 3s are 3. 1 3s are 3. That means if you observe carefully, remainder a power p divided by p, it is nothing but a. If a goes this side, it will become 1 by a. Yes or no? If it becomes 1 by a, it is nothing but a power p minus 1 by p 1. Are you all with me? A power p minus 1 is a power p into a power minus 1. A power minus 1 is 1 by a. 1 by a comes this side, it will become a. I hope it is clear. Fermat's theorem, Fermat's little theorem is derived from Fermat's theorem. Only thing is that multiply by a both the sides. If I multiply by a both the sides, 1 by a cancel. This will become a. A power p divided by p, it is a. A minus a. A minus a, it is perfectly divisible by p. A minus a, it is perfectly divisible by p. I hope the idea it is clear. Now we will solve this question. It's a very, very easy question. How many prime numbers are there such that 29 power p plus 1, 29 power p plus 1 is a multiple of p. Multiple means if 4 is a multiple of 2. 4 when divided by 2, remainder should be 0. 6 is a multiple of 2. Remainder should be 0. So if I apply theorem, let me apply theorem. Theorem is 29 power p minus 29 plus 30 divided by p. A power p minus a when is always divisible by p. That means 30 should be divisible by p. 30 should be divisible by p. What are p? P are prime numbers. P are prime numbers. What are the prime factors for P? 2, 3 and 5. 30 can be written as 2 into 3 into 5. Very, very easy question. Fermat's little theorem states, if P is a prime number and A is a natural number, A power P minus A, it is always divisible by P. Always divisible by P. A power P minus A. 29 power P minus 29. Always divisible. 30. It is anyway a multiple of P. So remainder 0. So 30 by P. Remainder 0. So P should be a factor of 30. Specifically, P is a prime number. P should be a prime factor of 30. P answer will be 2, 3 or 5. 2, 3 or 5. I hope the idea it is clear. Next one. What is the largest integer that divides n power 7 minus a? What is Fermat's little theorem? Fermat's little theorem is a power p minus a is always divisible by p if p is a prime number. If p is a prime number, a power p minus a, it is always divisible by p if p is a prime number. Just by observation, we can say that it is always divisible by 7. It is always divisible by 7. Step number 1. Step 1, it is always divisible by 7. But the question is largest integer. Largest integer. So let me expand it. Step number 2. N power 7 minus n. N into n power 6 minus 1. N into n square whole cube minus 1 whole cube. A cube minus b cube. A minus 1 into a square plus b square plus 1. N square minus 1 is n minus 1 into n plus 1 into n power 4 plus n square plus 1. These are three consecutive numbers. N minus 1, n plus 1. Difference is 1. These are three consecutive numbers. These are three consecutive numbers. Three consecutive numbers product, it is always divisible by 6. Three consecutive numbers. You take any three consecutive numbers, one number will be an even number. So definitely 2 will come. You take any three consecutive numbers, one number will be divisible by 3. 3, 4, 5. One number 3 is divisible by 3. 8, 9, 10. One number is divisible by 3. So one number is divisible by 3. And consecutive numbers, one number will be divisible by 2. So it will be definitely be divisible by 6. 1 into 2 into 3, divisible by 6. 8 into 9 into 10. 1 is an even number, divisible by 6. So this is divisible by 6, this is divisible by 7. Largest number is, it should be divisible by 42. Largest number is, it should be divisible by 42. Very, very good question. I hope the idea it is very clear. According to Fermat's little theorem, according to Fermat's little theorem, a power p minus a, it is always divisible by p if p is a prime number. A power p minus a is always divisible by p if p is a prime number. Step 1, step 2. These are three consecutive numbers. The product of three consecutive natural numbers. The product of three consecutive natural numbers is always divisible by 6. It is divisible by 6. It is divisible by 7. Next one. If q is a prime number, if q is a prime number, q plus 4 and q plus 14. Q plus 4 and q plus 14 are also prime numbers. So how many such q's are there? The lowest prime number, it is 2. 2 plus 4, 6. 2 plus 14, 16. 6 and 16 are even numbers. Not possible. If it is 3, 3, 7. 3 plus 14, 17. It is possible. Q it is 3. 3 plus 4, 7. 3 plus 14, 17. Any prime number greater than 3, it is of the form 6k plus 1 or 6k minus 1, 6k plus 5, 6k plus 15, 6k plus 15, 6k, it is divisible by 3, divisible by 3. It will become divisible by 3. 6k minus 1, it is 6k plus 3, divisible by 3, divisible by 3. So there is only one prime value for q, which will make other two also prime number. So answer is, how many such q's are there? Only one q is there, which will make q plus 4 and q plus 14 also as a prime number. I hope it is clear. Now, a lot on right after the class is over, take the prime number, watch all the sessions, maintain your own notes. Each and every concept that came from prime number across all management examinations we are going to discuss. How many numbers are there? Next question. How many numbers are there less than or equivalent to 500? How many numbers are there less than or equivalent to 500? Are there which is the product of more than 3 distinct prime numbers? More than 3. First, let us take 4. P1 into P2 into P3 into P4. Case number 1. Case number 1. Case number 2. Let me take 5 prime numbers. All are distinct, right? Let me take the lowest 5 prime numbers. Let me see if it is exceeding 500. Lowest 5 numbers. 2, 3, 5, 7, 11. 2, 3, 5, 7. 2 3s are 6, 6 5s are 30, 30 into 7. 2, 10, 2, 10 into 11, 2, 3, 1, 0. Number should be less than or equivalent to 500. That means only one case that is possible. Numbers which are less than or equivalent to 500, and the number should be written as P1 into P2 into P3 into P4. Let me take the lowest. 2, 3, 5, 7. 2, 3, 5, 7. 2 3s are 6, 6 5s are 30, 37s are 210. 210 is less than 500. Done. Let me take the next number by keeping the first 3 as it is. After 7, what is the next prime number? 11. 30 11s are 330. Done. 330. After 11, let me take the next number. 2, 3, 5. 11 next prime number 30. 6 5s are 30. 13s are 390. Done. If I take the next number, 2 into 3 into 5 into 17. 6 5s are 30. 30 17s are 510. It is exceeding 500. So this case we got. Next, I just replaced the highest value by the next prime numbers. Finally, I did right. So penultimate value I will do. 2 into 3 into 5 I will replace it with 7. 7 I will replace it with 11. 2 3s are 6, 6 7s are 42, 42 11s are 462. 42 11s are 11, 4s are 462. 462 is less than 500. Over. Next, 2 into 3 into 7 into 13. 91 6 are. It is not possible. Next one, I replaced 5. Let me replace 11. 2 into 3 into 11 into 13. 6 into 143. Not possible. So next, 2 into 5 into 7 into 11. 7 2 5s are 10, 10 7s are 70, 11 770. None of them it is going. Just a counting based problems. 1 2 3 4. I got 4 values which are less than or equivalent to 500, which can be written as the product of more than 3 distinct prime numbers. More than 3 means it can be 4, it can be 5, it can be 6. 5 onwards, the 5 minimum value itself is 2310, that to the smallest 5 number, so it is not possible. So I started with 2 3 5 7. I replaced the highest 7 with the next prime number. I got a value where it is exceeding. I stopped. Then I went into the next value. When I went into the next value, just a counting based problem. Now, another question. A 3-digit number ABC is written side by side. ABC, ABC. Yes. Then which of the following it is true? Already we discussed. Any 3-digit number written even number of times. Any 3-digit number written even number of times. Any 3-digit number written even number of times. It is always divisible by 7, 11, 13. Any 3-digit number written even number of times is always divisible by 7, 11, 13. Finish. Any 3-digit number written even number of times is always divisible by 7, 11, 13. A logical question. A number of positive values such that the product is n minus 1. This is a previous year CAT question, sir. N minus 1, n minus 2, n minus 3, and so on up to 3 into 2 into 1, which is n minus 1 factorial. What is the concept? N minus 1 factorial is not divisible by n. Is not divisible by n. Yesterday we discussed n minus 1 factorial is not divisible by n as long as n is a prime number. As long as n is a prime number. N is a prime number and n equivalent to 4. Very, very important concept, sir. N minus 1 factorial not divisible by n when n is a prime number and n equivalent to 4. Suppose take a composite number n equivalent to 6. 6 minus 1 is 5 factorial. 5 factorial. 5 factorial. It is divisible by 5. 5 factorial. It is divisible by 5. Now see here. As long as n is a prime number, n equivalent to 5, if I take 5 minus 1 factorial, 4 factorial. 4 factorial is not divisible by 5. I hope the idea it is clear. Now you can write all prime numbers 13, 17, 19, 23. 29, 31, 37. It is ranging from 12 to 40. It is ranging from 12 to 40. So 13, 17, 19, 23, 29, 31, 37. Idea clear? Very, very easy question. But if you know this concept, you can solve it very, very easily. N minus 1 factorial is not divisible by n as long as n is a prime number and n equivalent to 4. If I take n equivalent to 1, 6 minus 1 factorial, 5 factorial is divisible by 5. 5 factorial is divisible by 5. Next one. Next question. If m is the number of prime numbers between 0 and 50, between 0 and 50, there are 15 prime numbers. Between 0 and 50, there are 50 prime numbers. And n is the number of prime numbers between 50 and 100. Between 50 and 100, there are 10 prime numbers. There are 10 prime numbers. So m value it is 15, n value it is 10. 15 minus 10. 15 minus 10. Answer is 5. Simple question. If you know the concept that number of prime numbers from 0 to 50 are 15, number of prime numbers from 50 to 100 are 10. 15 minus 10, the answer is 5. Next one. What is the smallest 3-digit prime number? What is the smallest 3-digit prime number? N should be the 1 minute, sir. N should be the smallest 3-digit prime number. What is the smallest 3-digit natural number? 100. So 100, is it a prime number? No. 100 is divisible by total 9 factors. So the smallest 3-digit will be after 100. What is the next number? 101. Smallest 3-digit prime number. Smallest 3-digit prime number will be 101. Lowest 3-digit number will be 100, but it is a prime number, so it is 101. It is 101. I hope the 1 minute, sir. $101. Now see here. What is the question? N is the smallest 3-digit prime number when n is divisible by 101. When n is divisible by 101. Sorry, n is divisible by 13. 101 divided by 13. 13 sevens are 91. What is the remainder? 10. 13 sevens are 91. What is the remainder? 10. Very, very easy question. Only thing you have to do is, we have to find out the lowest 3-digit prime number and divide it by 13. And divide it by 13. All odd prime numbers. Unit digit in the product. You don't need to do all these. 5 into any number. 5 into any number. 5 into any number. Unit digit will result in 0 or 5. 0 when it is multiplied by even number. When it is multiplied by even number. 5 4s are 20. All these 24 numbers, you don't need to write it. I am writing it. What if the question is, right? Not excluding 5s if I take, then probably all the prime numbers after 10 are multiplied. Then that is the process. You don't need to write all this. These ideally you should ignore it. Ignore it for this question because 1 5 is there. 5 into any number. Unit digit will be 0 if it is multiplied by even number. If it is multiplied by 5 multiplied by any odd number. 5 multiplied by any odd number, unit digit will be 5. 5 multiplied by any odd number, unit digit will be 5. 5 3s are 15, 5 7s are 35, 5 9s are 45. Remaining all are odd numbers. So answer is just a 5 seconds. Answer is 5. What is the logic? 5 multiplied by any number. 5 multiplied by any number, unit digit will be 0 or 5. You will get 0 when the other numbers which are getting multiplied by 5 are even numbers. If all the other numbers are odd numbers, these are all odd numbers. 5 multiplied by any odd number, just to show that all the other numbers are odd numbers, I just wrote it. It is 5 multiplied by any odd number, answer is 5. I hope the idea it is clear. Next one. This question already we did it. Find what is the value of x such that x plus 2 and x plus 4 all are prime numbers. So lowest prime x equivalent to 2, 2 plus 2, 2 plus 4. Not 4 and 6 are even numbers. If it is 3, 3 plus 2, 3 plus 4. 3, 5, 7. It is a prime number triplet. Yesterday we did the same question. Any prime number greater than 3, 6k plus 1 or 6k minus 1. It is 6k plus 3. Not possible. 6k minus 1 plus 4. 6k plus 3. Not possible. Only one value x can take, and that value of x is 3. So how many values x will take such that these x plus 2, x plus 4 is a prime number. X value it is 3. Already we did the question. Good number of problems we discussed. Another question which I took it out from a mock paper. N square minus 33. N square minus 33. N square minus 31. N square minus 29. N square minus 29. All are prime numbers. All these three are prime numbers. All these three are prime numbers. What is the number of possible values of n such that n is an integer? The domain of n is an integer. N should be an integer. N square minus 33, n square minus 31 and n square minus 29. These difference is 2. These difference is 2. So in a prime number, is there any triplet? Is there any triplet which is in arithmetic progression? Yes, which is 357. Which is 357. 235, it is not in arithmetic progression. 357, it is in arithmetic progression. 5, 7, 11, no. 7, 11, 13, no. 11, 13, 17, no. 17, 19, 23, no. So the only prime number triplet which is in arithmetic progression, it is 3, 5 and 7. 3, 5 and 7. So it is 3, 5 and 7. So n square minus 33 equivalent to 3. N square equivalent to 36. N value will be plus or minus 6. How many values? What is the question he is asking? He is asking n is an integer. So n can take 6 or n can take minus 6. 6 or minus 6. How many values it can take? 2 values it can take. It's an previous year, I think 5 or 6 years before, this question came in career launcher mock paper. N square minus 33, n square minus 31, n square minus 29 are prime numbers. These triplets are going with a difference of 2. So the only prime number triplet which goes with a difference of 2, it is 357. I hope the idea it is clear. Next one. Sum of 3 prime numbers. Sum of 3 prime numbers, it is 100. Sum of 3 prime numbers, it is 100. We do not know the nature of a prime number. Suppose all the 3, can it be even? All the 3 cannot be even. Why? Because in a prime number set, only there is one number which is even. This is not possible. Next case, all P1, P2, P1, P2, P3. Can it be odd? If it is odd, odd plus odd, even. Odd plus odd, even. Even plus odd, it is odd. Odd plus odd, even. Even plus odd, it is odd. It is odd, but 100 is an even number. All the 3 cannot be even primes. All the 3 cannot be odd primes. That means one has to be even. One has to be even. Only when one is even, other 2 can be odd. Other 2 can be odd. If one has to be even and other 2 has to be odd, other 2 has to be odd. Odd plus odd is even. Even plus even, it is even. So 1 will be 2. If 1 is 2, let P1 will be 2. P1 plus P2 equivalent to 100. P1 plus P2, it is 98. P1 plus P2, P1 plus P2, it is 98. If I plug in the answer, I'll play with the answer options. P1 plus P2 is 98. If these 81, these 17 plus 81, not possible. If these 43, it is 55, not possible. It is 29, it is 69, 31, it will be 67. 31 plus 67. I used the answer option. 31 plus 67. 67, 31. Difference is 36. These satisfied. These satisfied. Very easy question. Sum of 3 prime numbers, it is an even number. All the 3 even cannot be possible. So 1 can be even. So 2 plus P1 plus P2, it equivalent to 100. I hope the idea.